Hi and Assalamualaikum. My name is Nur Amira Shamimi binti Makna. My matric number is 180157 and my supervisor is Technologist Zarizi bin Awang. My co-supervisor is Technologist Dr. Nurhanis Hayati binti Hairom. My final year project 1 is about the first stage reusability of zinc oxide clay photocatalyst in membrane photocatalytic reactor (MPR) for POMC treatment. This is my presentation outline, which is I will start with introduction, then literature review, methodology, expected result, and then Gantt chart. So for background of study, Malaysia is the second largest producer of palm oil in the world with a production of 17.32 million tons in 2016, and the production of palm oil lead to huge amount of wastewater generation known as palm oil mill effluent, which is POMEF, and the pollution problem related to palm oil mill secondary effluents (POMSE), and POMSE is produced from secondary biological treatment for POME and also known as advanced treatment. So the study report on the reusability of zinc oxide clay for POMSE treatment via membrane photocatalytic reactor (MPR), which is zinc oxide clay as a photocatalyst. Photocatalyst process is one of the promising method in wastewater treatment. So this is my problem statement, which is first is the impact of the production of a large volume of waste. Next is POME is not the only waste produced during the processing of fresh fruit bunches, but also costly and difficult waste for mill managed to handle. It is because the conventional POME system use bonding system, and the maintenance of bonding system are quite expensive. Next is POMC has major disposal problem which could not be discharged even undergo a series of treatment. So the photocatalyst use has the ability to reduce the pollutant in POMC, but it will increase the chemical usage, also increasing cost of the treatment. So this is my objective of study, which is first is to synthesize the optimum ratio of zinc oxide clay at optimum condition via precipitation method. Second is to evaluate the reusability of zinc oxide clay in the first stage, which is cycle 1 until 10 for POMC treatment via MPR. Next is to characterize zinc oxide physiochemical properties before treatment, which is 0 cycle, and after treatment, which is 10 cycle of reuse. So the significance of study is to evaluate the reusability of zinc oxide clay in the treatment process, which can reduce operating costs to be valuable to the industry. Second is to demonstrate the water quality with high reduction of COD, BOD, and turbidity, and also color. Next is treated POMC quality to comply the standard discharge requirement according to Environment Quality Act 1974. Next is a solution to the palm oil industry through the sustainable approach and greener technology, as well as can reduce cost and also can reduce the chemical usage. This is the scope of study. First is to synthesize zinc oxide clay at optimum condition by using precipitation method. Next is characterize zinc oxide clay by using FTIR, XRD, and also FAST. Photocatalyst is a material which decomposes detrimental substance under the sunlight, contain UV ray, and photocatalyst will absorb light to increase energy level and then transfer the energy to responding substance to cause a chemical reaction, which is the photocatalyst will go under reduction and also oxidation. Next is function of photocatalyst, which is degradation that lead to self-cleaning effect and also superhydrophilics. The type of photocatalyst reaction has two, which is homogeneous and also heterogeneous. The homogeneous is when the both semiconductor and reactant are in the same phase, either solid, liquid, and gases. The heterogeneous is when both semiconductor reactant are in different phases. Okay, for photocatalyst application, Actually, photocatalyst treatment has been widely applied with various industries due to its advantages. It is because photocatalyst has better performance and also more efficient than the conventional treatment. For example, zinc oxide dimboprogon citratus in POMC treatment, the MPR has shows a better treated POMC quality. Next is reusability of photocatalyst, which is the reusability of photocatalyst in photocatalyst process was successful in the remediation of wastewater despite slightly reduced performance after conducting a few cycles of consecutive run. And there are two types of reusability method, which is oven drying method and also hot water rinsing method. For the POMA treatment, oven drying method are the most efficient treatment. So this is the summary of literature review from the previous study of reusability photocatalyst and also the photocatalyst application. For the chapter 3 is methodology. This is the material and chemical used in this experiment, which is zinc oxide clay. Zinc oxide clay deionized water, mercury sulfate, potassium dichromate, silver sulfate, ferrous ammonium sulfate solution. And this is all the equipment used, which is UV lamp, vacuum drying, FTIR, XRD, PSM, and also magnetic hot plate stirrer. So this is the flowchart of my experiment, which is we'll start with synthesis of zinc oxide clay. Next is POMC treatment, which is at this stage the quality POMC will be analyzed, which is we will analyze the COD, BOD, color, and also turbidity. Next is characterize the zinc oxide clay at 0 and 10 cycles by using FTIR, PSM, and XRD. So for method of synthesis is by using precipitation method. So a few amount of clay will be added to the mixture after a few minutes of reaction to form a zinc oxide clay. Then the mixture will be stirred and at room temperature for the several hours, and then filter and dried for 1 hour at 100 degrees Celsius in the oven to remove the surplus water. Then the precipitate will be calcined for an hour at 550 degrees Celsius in the furnace. Okay, next is reusability of zinc oxide method. As I mentioned before, I will use oven drying method. It is because it's more efficient in water treatment. So the zinc oxide clay photocatalyst will be recovered after the photocatalytic treatment and will be run with water, then dry at 100 degrees Celsius in an oven for 5 hours. Then the photocatalyst will be ready to be used in the next run. So next is to analyze the POMC quality, which is to measure color, BOD, COD, and also turbidity. For color, it will be measured by integral spectrometry, which is color of matter will be determined by its selective absorption of light at different wavelength. For BOD, two samples will be collected and one sample will immediately test and the other sample will be incubated in dark for 5 days at 220 degrees Celsius and then measure the DO remaining. So the difference between two sample oxygen level is the BOD. Next is COD, determine COD. So COD will be determined by titration method. First is add mercury sulfate and then mix and swirl. Then add potassium dichromate into solution. Next is add silver sulfate sulfuric acid and then let it digest and cool. And then add titrate solution and next add ferrous ammonium sulfate. For turbidity will be determined by turbidity meter. So all the sample for each cycle will be collected and measured by the turbidity meter. So for the characterization of zinc oxide clay will be measured by FTIR, XRD, and also PSM. So FTIR is Fourier transform infrared spectroscopy. Uh, it is used to characterize the chemical bond. So the FTIR spectra will be obtained directly on a powdery sample, repeating the acquisition for 2 times. And XRD is the X-ray diffractometer. The function is to analyze purity and crystallinity of zinc oxide clay. The data will be collected at room temperature in range of 2 theta, which is 10 until 80 degree. Next is PSM, which is field emission scanning electron microscopy. So the sample will be sputter coated with platinum, and the accelerating voltage will be set at 5 kilovolt during the analysis. Lastly is the expected result. So this study helped us to understand to what extent the photocatalyst will be able to perform the POMC treatment via MPR, and the zinc oxide is expected to be successfully synthesized and also characterized in terms of morphology, crystallinity, purity, and chemical bond by using FTIR, XRD, and also PSM. Next is the water quality are expected to improve with higher reduction of COD, BOD, turbidity, and color by using photocatalyst zinc oxide clay in this POMC treatment. And lastly is the treated POMC quality will comply with standard discharge requirement according to Environment Quality Act 1974, Act 127. So next is Gantt chart. So this is Gantt chart or my experiment or project planning. So that's all from me. Thank you.